Before we delve deeper into AI, agentic AI, and all those topics, I want to quickly give you some AI fundamentals, how it works, and what you need to understand before you can fully grasp the complete AI solution we're aiming to build. So let's dive in. AI is like a family. Know which member you're talking to. Suppose you're talking to artificial intelligence. So this is a big field, meaning anything that can be intelligent, any software that falls under the artificial intelligence system. Machine learning is a type of system that learns patterns from data instead of following handwritten rules. That means it's not following any rules. It's simply understanding the data, creating patterns, and then figuring out what you're trying to do with the data. A better approach is deep learning in machine learning, which uses large neural networks, the engine behind the recent boom. This means how they can learn quickly. In other words, ML is like a system that is learning. But how can they learn more deeply about a subject or a particular area? That's where deep learning comes in. That's why the recent boom is happening. In the past 2 years, AI has changed everything because of deep learning. Then we come to generative AI and LLMs. So, models that can create text, images, code, and video like ChatGPT, Claude, Gemini, and all the other available models we have right now. This series is about the innermost box. LLMs, because they are the first AI that works with everyday business language. Okay, so let's dive into that part. So, traditional software versus machine learning. In traditional software, we create our own rules, like if X, then Y. If I provide this input, you will provide this output. It breaks the moment. If the input doesn't match the rules, meaning if you change something, it won't adapt. If something new comes in, it will give you an error and the system will fail. Okay, for example, if the order total is greater than the credit limit, hold it. That's how it used to work in traditional software. In machine learning, the system learns the rules automatically. By looking at your data and patterns, you show it the data and the outcomes. It finds the pattern. The output is a prediction with a confidence level, not a certainty. Systems are getting more advanced day by day, but it takes time. So suppose you implement something today based on just a part of the data. But if you work with the same system for 2, 3, or 4 weeks like an experienced employee, it will give you better results, more confident results. Because it has gained that understanding of how your business is doing, what your patterns are like. That's why machine learning is important. Once you start providing the data, it will begin running and creating the patterns. The best part is that it's also going to handle messy, never-before-seen inputs gracefully. That means it's not going to say, oh, I see this new thing. No, this model. Machine learning models are very powerful. They will detect and respond to those new inputs as they come in. It won't just stop working. Unlike current systems, where you were sending everything as 040404, and now if you send 05, no data comes in. But machine learning will provide you with something that's highly relevant based on the patterns it has learned, so it won't. It's intelligent because it's discovering more patterns in the system, patterns you don't know about that you've never uncovered. So here, for example, you have 10,000 past orders. Learn what risky looks like, right? It will find a way and give you more detailed information from the input you receive. It's not going to replace ERPs. Machine learning gets added exactly where rules can't handle things. Like we're talking about EDI, right? We encounter different types of errors and people get scared. That's where this system is going to come in. It's going to give you the pattern and suggest something like, I think if you match this with that, it will solve the problem. And based on your acceptance of the patterns it suggests, it will automatically improve day by day. Moving on to the next chapter. So what does a large language model actually do? Given the text so far, it predicts the next word. This is repeated billions of times across most of the written internet. That single skill enables it to draft, summarize, translate, classify, and reason in plain language. It's all about pre-training, fine-tuning, and then your prompt. Meaning, if you provide the context and details you have right now, you're essentially training it, and then it's based on those assumptions. Or the pattern it forms or the alert it gives, you're giving it confidence. Oh yeah, you're doing it right, just like guiding a new employee or teaching your child. This way is correct, that way is incorrect. Gradually, it will become more powerful, providing you with autonomous alerts and results, and it will be great for whoever uses it. Then, based on your questions, it will answer you. You won't have to go back and teach them for a long time. All those patterns you taught earlier, the model will save them and provide you with better results based on that. So we need to understand tokens and the context window. This is very important because we need to know how many tokens will be used, because everything you do on AI platforms, whether it's an assistant or agentic AI, will cost you some kind of money, power, or resources. So, if you take a close look at every single piece of text, just like the current example we are seeing here, roughly about 3/4 of a standard word is what we typically refer to as a chunk, or more technically, a token. So every API call we make will charge you in some way. The number of tokens you use is what you have to pay for. For long documents, more tokens mean higher cost and more time. For example, roughly every 1,000 tokens, 750 words, it's going to take some time to get you the result, and both the incoming and outgoing tokens need to be calculated. The charges are based on that, meaning if you're asking A and answering B, C, D, both will be charged. You need to manage the context window, this and that part. It's like memory. Suppose you started a chat in the morning and you keep doing the same kind of thing in the same chat window. It will save the memory and give you better results, and thus it will use sorted tokens. So because it's context, it means you've created a context window. So whatever you're talking about, for example, you started in the morning discussing how you can solve the automation problem in EDI, like complete EDI automation. And you're asking the same questions, discussing and giving your inputs. It will retain that memory that you're talking about EDI, and it will gather all those things related to EDI and put them into that context window. So whenever you ask similar questions, it will give you better results. So you don't have to keep providing the full context again and again. So you've already saved the memory and you'll get the results. Okay, and if you switch, like most people make this mistake, they keep switching. Starting a new chat means you're not allowing your AI to get trained on it, to get trained about you. It's not going to know your patterns. It's not going to know how you write better emails. What you accept, what you don't accept, what you don't like, it's not going to know that. That's why it's very important to keep the same chat for the same type of topic you're discussing. If you're talking about AI assistants like Copilot and all those things, let's move on to the next part. Why does it sometimes make things up? That's very important to understand. AI has a lot of knowledge. Just like we sometimes ourselves, sometimes give the wrong answer. So the AI does the same thing again and again. All right then, if you are wondering what, it is actually commonly referred to as, you have to. Whatever it's producing, you need to double check. That's the bottom line of this whole screen. It predicts maybe something that is wrong. There's no database inside, so if there's no lookup, no fact table, no fact check, it means the knowledge is baked into patterns. It depends on the training cutoff date, and it's going to give you different types of results. And the worst part of AI is that whatever you ask, it will give you something. That means it won't say, I don't know, and that's the problem. That's where this kind of hallucination comes in. It will give you wrong answers. So where you have to be alert about this is knowing that you should double check your data. And it will take time to build. That pattern means, suppose you started on day 1 or week 1. It may hallucinate a lot at first, but as you feed it more information, more patterns, more data, and check, double check, and triple check the data, and you're providing your team, who is working with that agent, with a tremendous flow of data that you're generating right now. How do you do it? After 4 or 5 weeks of training, or even 10 weeks, it will get much better and give you more accurate answers and more accurate data. That's why everyone talks about pre-training, fine-tuning, and then giving the prompt. That's why with that kind of model, you have to train the data. They have trained the LLM because without a trained LLM, it's basically like a garbage machine. If you just ask it questions, it will answer anything at all. So you need to set boundaries for it. That way, it knows when it has something to say, and otherwise, it shouldn't say anything. What are LLMs reliably good at, and what are they bad at? So they're reliable at summarizing long, messy texts, drafting emails, documents, job descriptions, code, classifying things, extracting region codes, fields from PDFs, translating formats, notes, tables, EDI codes, English, right? They can explain code, contracts, jargon, errors, but they're a bit weak when it comes to exact arithmetic at scale. When it comes to current events and live data, that's very bad. That means, well, it's better, but current events are difficult because it's generating patterns from news and all those things. Maybe that's wrong. Counting things precisely, like how many are on this page. Okay, sometimes it sees things differently. So you have to be aware that it might not be 100% accurate. Consistency across thousands of repetitions. Because you are continuously asking, give me this, give me this, give me this, and everyone is making requests. Sometimes it makes mistakes understanding your company. You have to provide the correct context. Otherwise, it will give you something else. That's why it's very important to always fine-tune your agent. Let's move to the next point. Models like Claude, GPT, Gemini, and Llama differ in capability, speed, and price. You deploy them. Swapping them later is easy. You can see you can download the Llama model, set it up in your local environment, and work on it. It will charge you something based on their pricing. Thank you. There are many users and different types of models, and there are plenty of models available in the market now. Chat apps are mostly, you could say, the showroom. The models were engines, chat apps like ChatGPT, Claude, Copilot, a person typing in a window. Great for individual productivity and learning APIs. The same brains can be called from your own systems and workflows. This is where business automation happens. So whenever we need automation, we have to use APIs. We cannot work with cloud code. We have to use cloud APIs because we need to send something, or we can use local models. We set up our own environment and all those things. Both are fine, but APIs are faster. We don't have to set it up and fine-tune it because it doesn't require much fine-tuning. APIs are easier and the models will be as well. You have to set it up, provide the context, and train it. That means for every department. For example, if you get EDI, you have to train everything for EDI, one model. For the second model, you have to train everything for cash flow, something like that. Next, open versus closed. Closed cloud in GPT. The best capability vendor hosted. Open means closed means it's hosted or managed by the big companies and is available. They are selling it, providing it to you for use. Open Llama is self-hosted. Control means you have the most control. With closed, you start by setting up your environment and then you can work from there. Model sizes. Big models offer deeper reasoning but come at a higher cost. Small models are cheap, fast, and suitable for routine classification. Mix them according to the task. It totally depends on how you're going to use it. Big models are going to be expensive, while small models are cheaper. Enterprise plans. The business versions add the features that matter. Data not used for training, admin controls, audit. That's what we're doing right now. Cloud Code is for enterprise. So our data is being used within the organization. Whatever we talk about or discuss on Cloud Code, it doesn't go outside